We're going to look at a Fibonacci sequence now. So a Fibonacci sequence is such that every number in the sequence is the sum of the two preceding numbers, as we can see in Wikipedia, right? So that means that f of n, so at any given point, equals the sum of f of n minus 1 plus f of n minus 2. So this would be like 3 and then 2 and 1. So this notation just shows which entry in the sequence it is. So f of 3, or f sub 3, would be the third number in the sequence, equals f sub n minus 1, so 3 minus 1, 2, and then f of 1, right? So that means that the third number in the sequence equals the value of the second number of the sequence plus the value of the first number in the sequence, okay? And we can look at this pretty easily in, the first few values, right? So let's pick one, 8. 8 equals 5 plus 3, okay? 21 equals 13 plus 8. And you can do this for every number, and it just keeps on going up, okay? So let's actually program this recursively in Python. We'll create our function called def Fibonacci, and it's going to put in some number. And our goal is we're going to input the number, so it's which number in the sequence it is, and is going to return the value, okay? So f sub 0 is 0, and f sub 1 is 1. So we know if we input 0, it's going to be 0. Otherwise, if it's 1, we're going to output 1. So let's start that. If number equals 0, we're going to return 0. Elif number equals 1, we're going to return 1. Okay? So this is where we're going to get into the recursive part. This, is easy because we already have these as givens. But now we have to look at it, okay, f sub n equals f sub n minus 1 plus f sub n minus 2. But we can look at this just as a function, right? This function of a number equals the same function of the number minus 1 plus the same function of the number minus 2. So we return that. And the way we type that in would be else return Fibonacci number minus 1 plus Fibonacci number minus 2. Okay? So now we're going to have a few tests. Fibonacci in the 0. Okay, we'll do 1, 2, 3, 4, 5. Okay, and we obviously could have done this in a for loop, and we will. So we'll run it, and we get 0, 1, 1, 2, 3, 5. Okay, so if we were to go back to Wikipedia and we look at the first two, 0, 1, 1, 2, 3, 5. That's perfect. Let's say we wanted to output or print the first 100 numbers of the sequence. We can do for I in range 0, 100, print Fibonacci of I. Okay, we run it. Oh, simple error. There you go. It's going to keep on going. And it takes longer and longer because of just the complexity of the algorithm. And when you learn about big O, you'll understand why it's taking longer and longer and longer. But if we wanted to stay here, we could figure it out. Let's give the computer a break and stop. But these are all the numbers in the sequence, okay? And we can see 8, 13, 21, 34, 85. We go over here, and it's the same one, okay? So that's it for this lecture, and you have an assignment next.